TYBSc friends, those who are appearing for the Savitribai Phule Pune University Pune final examination, multiple choice question type of examination that is to be conducted in October 2020. In this video, we are going to discuss few important questions from first three chapters on the physics paper 3, that is Thermodynamics and Statistical Physics. Before I start discussing these questions, let me say thank you to Dr. Sunanda Pisal ma'am, Honorable Head, Department of Physics, S.M. Joshi College, Hadapsar, Pune, for providing these questions for discussion in this video. So as we all know, this is one of the important paper wherein there can be several simple questions can be asked which are based upon different physical phenomenon or the concept we study in the thermodynamics and statistical physics. So in today's video we are going to see three chapters, so questions based upon first three chapters. Let's start with one by one. First one is, which of the following are transport phenomenon in gases? So four options are given. First one is viscosity, second is thermal conductivity, third is diffusion, and fourth is all of the above. As we all know, all transport phenomenon are possible because there is something, so something gets transferred, and because of that these phenomena get exhibited by the gases. So we know that viscosity comes because of the momentum transfer, thermal conductivity comes because of the heat transfer, diffusion comes because of the mass transfer, and therefore all of the above is the correct answer for this question number 1. Second, as we have discussed just now, viscosity is due to transport of momentum, transport of energy, transport of mass, and none of the above. So momentum transfer or the transport of momentum plays a very vital role in the phenomenon that is called as viscosity. So question 2, option is 1. Third is thermal conductivity is due to, again options are same, transport of momentum, transport of energy, transport of mass, and none of the above. So actually it is transfer of heat energy or transport of heat energy. So that is the phenomenon that takes place because of the transport of energy, and that is called as thermal conductivity. Then question number 4, diffusion is due to transport of momentum, transfer of energy, transport of mass, and none of the above. So of course there is a molecular mass gets transported from one location to other location or one layer to other layer of a liquid in non-equilibrium situation or condition. So that phenomenon is nothing but the diffusion, or that takes place because of this transport of the mass. Then fifth question, which of the following is assumption of kinetic energy of theory of gases? There are 4-5 options are given. So let's check one. A gas consists of large number of extremely small molecules. That is one of the assumption. The molecules of gas are considered to be rigid, perfectly elastic, and identical. That is also true. Then force of attraction or repulsion between the gas molecules is negligible. That is what we say, that there is whatever potential existing between this is simply zero. So there is no force of attraction or repulsion between the gas molecules, or it is almost negligible. So all of these above are the assumptions or the basic assumptions of this kinetic theory of gases. Therefore question 5, answer 4 is the correct one. So it is all the 5. Then question 6, average kinetic energy of gas molecule is directly proportional to dash dash of the gas. Now let's check the options. First option is mass, second is temperature, third is density, and fourth is the none of the above. So it depends clearly on the temperature or absolute temperature, that is T. So here this particular question number 6, correct option is 2, that is absolute temperature. Then question number 7, which of the following equation of state of ideal gas? So which is the equation of this? So V is equal to mgh, this is the potential energy in classical mechanics. PV is equal to nRT, that can be one solution here. F is equal to ma, that is again not at all related here, so it is Newton's second law of motion. And F is equal to U minus Ts, this is Helmholtz free energy of a gas or the thermodynamic system. So here correct answer is this, PV is equal to nRT, that is the equation of state of an ideal gas. Then question number 8, mean free path is the distance between two molecules, distance between two collisions of the molecule, average distance traveled by molecule between two successive collisions, and option 4 is diameter of the molecule. So in our discussion we have learned that suppose this molecule, it goes here, it strikes with this another molecule, gets reflected, again strikes here the third molecule, then also gets reflected, and like that. This type of zigzag motion is called as the motion of the actual molecule or whatever molecule we have considered in the gas. Now this is first collision, this is second collision, this is third collision, and if I go on calculating the average distance traveled over all these collisions, that is nothing but the mean free path, and that's what the option 3 is the correct answer. Average distance traveled by molecule between two successive collisions. So this average is to be computed or calculated, and that gives you mean free path of the substance or the gas. Question number 9, which of the following equation represents Helmholtz free energy? Of course there are 3 such questions have been given, so we'll see one by one. So Helmholtz free energy is defined by or is described by the symbol F. Then enthalpy is defined by H, entropy is defined by this S, and G is the letter used for Gibbs free energy. So this is Gibbs free energy, this is entropy, it is enthalpy. These are the different physical parameters or terms we use in thermodynamics, and this is called as Helmholtz free energy. So naturally this H is enthalpy, this is not correct here. G is equal to U plus PV minus Tc, this is also not that. And this equation Q, dq is equal to Tds, this is your second law of thermodynamics. Second law of thermodynamics. So naturally the correct answer of this question number 9 is F is equal to U minus Ts, where this U is internal energy. And we also remember that this capital T represents absolute temperature or simply temperature. So we must understand or we must know these different types of physical parameters that are used in thermodynamics to describe the state of any of the thermodynamic system. Question number 10, which of the following equation represents Gibbs function? So again F is equal to U minus Ts, this is Helmholtz free energy. H is equal to U plus PV is the enthalpy. dq is equal to Tds is, as I said earlier, it is the heat absorbed or evolved, and this is what your second law of thermodynamics, and therefore option 3 is the correct option. That gives you the Gibbs free energy or Gibbs function. G is equal to U plus PV minus Ts. Then question number 11, which of the following equation represents enthalpy? So as I said, so this has gone, this is Helmholtz free energy, this is the Gibbs free energy, this is the second law of thermodynamics. So correct answer remain is this, H is equal to U plus PV, that represents the enthalpy of a thermodynamics system. Then question number 12, in Joule-Thompson effect, which gas, when a gas under high pressure is allowed to pass through a porous plug to a region of low pressure, its temperature is, so that is what called as Joule-Thompson effect, and whenever such type of case occurs, the temperature of that gas is reduced considerably, and therefore to lowered. That is the correct option of this question number 12. So this is called as Joule-Thompson effect, and here we know that when this is a nozzle, and where the high pressure gas is allowed to expand in a low pressure region. This is what a region, it's a low pressure region, and now when this gas gets expanded here at this nozzle, the temperature of this is found to be very, very low, or temperature is reduced. So this effect is called as Joule-Thompson effect in the thermodynamics. Question number 13. The boil temperature is temperature at which the product PV, that is, increases, decreases, remains constant, and option 4 is both increases and decreases. So here this correct option of this is it remains constant. So product of pressure and volume remains constant, and such type of temperature is called as boil temperature of the gas. Then question number 14. The temperature at which Joule-Thompson effect is 0 and changes sign is known as, this is what, so when this particular temperature is reached, beyond that temperature, instead of cooling, there occurs heating. So this temperature is called as temperature of inversion. So boil temperature already we have seen, PV is equal to constant. Temperature of inversion is the temperature is where this particular type of Joule-Thompson effect gives heating instead of cooling. Critical temperature also is not applicable here, and therefore correct option of this question number 14 is 2, temperature of inversion. Now further few questions are related to first and second law of thermodynamics. So question number 15, which of the following is statement of first law of thermodynamics? So this is what first statement, dq is equal to tds, as I already said. This is second law of thermodynamics. H is equal to U plus PV, that is the enthalpy function given. G is equal to U plus PV minus Ts, this is the Gibbs free energy, and therefore dq is equal to du plus pdv, or sometimes it is given as dq is equal to du plus dw, work done. So that is also given by this pdv. Sometimes this dq is given by tds is equal to du plus pdv. So all these are the statements of the second law of the first law of the thermodynamics. So here the correct option of this question number 15 is 4, dq is equal to du plus pdv. Question number 16, which of the following statement is the second law of thermodynamics? As I said, this is enthalpy, this is Gibbs free energy, and this is first law of thermodynamics. So the correct option remains here is this dq is equal to tds, that is called as the entropy, or we know that relation for entropy is given to be, change in entropy is given to be heat absorbed or evolved at that temperature. So this ratio of heat absorbed at that temperature, or at some temperature that is expressed in absolute temperature, then this amount of heat absorbed but that ratio is called as entropy of the system. So dq is equal to tds is the equation, mathematical expression for the second law of thermodynamics. Then question number 17, in adiabatic process dp is equal to 0. Actually this process is called as no change in the pressure, that is called as isobaric process. No change in temperature, or dt is equal to 0, that is actually this is not correct. This is dt is equal to 0, this is called as isothermal process. dv is equal to 0, there is no change in the volume of the system, and that is called as isochoric. So this is isobaric, this is isothermal. This process is dv is equal to 0, called as isochoric, and therefore the remaining process is this is called as adiabatic process. And as we know from the definition, in adiabatic process no heat is allowed to exchange. So heat of the system that remains constant, and therefore dq is equal to 0 is the process which we call an adiabatic process in thermodynamics. Question number 18, probability of an event is, okay, this is again a very simple question, the ratio of number of cases in which event occurs to the total number of cases. The total, option B, or second option is the total number of cases. The C, or third option, is total number of events, and D, that is 4, none of the above. So first number, option 1 is the correct option, that tells you the probability is that of a particular event is the ratio of number of cases in which that particular event occurs to the total number of cases that we have been observing. So question number 18, option is 1. Correct option is 1. Then question number 19. Suppose we toss a coin, then the probability of head may come up is. So every coin has two sides, either head or tail. So whenever we throw this coin or when we toss a coin, it is invariably either there will be head or tail, and there is a 50% chance that head will come and 50% chance that tail will come, and therefore however such large in the number of events are also carried out, you will find that the probability of occurrence of the head may be again 50%, and that suggests it to be 1/2 or 50%. So this can be given in either, I can give this in the 100%, or can give given 50%, can be given in 25%, or can be given in 0%. So this particular question can be given these type of options too. So again the correct answer is 50%, or this is 1/2. So that is question number 19. Question number 20. Probability of occurrence of two events simultaneously or in succession. So that is what event 1 and event 2 are occurring simultaneously, and whenever such a case is there, the probability P of the event P1 and P2 is given by, total probability is given by product of P1 and P2. So this is multiplied, and this is what the problem number 20. Here the product, first option is product of probability of individual events, then the addition of probability of the independent events, and both E1 and 2, and option 4 is none of the above. So in that case, whenever two such simultaneous events are occurring, the probability gets multiplied, and therefore option 1 is the correct option for question number 20. Then question number 21. Two events are said to be mutually exclusive. That means if one event occurs, second will not occur. For example, head and tail. If I toss a coin and head comes, then there is no chance, no tail won't come, or if tail comes and then there is no head will come. So in that case, that type of case is called as the mutually exclusive type of events. So if two events are said to be mutually exclusive, if both events occur simultaneously, occurrence of any of them prevents the occurrence of the other, both 1 and 2, and option 4 is none of the above. So that is what option 2 is the correct option of this question number 21, which tells you that occurrence of one event prevents the occurrence of the second one. Now next are the few questions which are related to the random walk problem. So here question number 22. In random walk problem, mean number of steps taken to the right n1 bar. Okay, so you might have understood this. This is my origin. So right steps on the right are taken by this on this side, first, second, third, etc. Steps on the left are taken to be n2 on this side. So probability of occurrence of the step on the first right hand side is P1 or P, and here it is Q. And in any event, this P plus Q is always equal to 1. So probability of occurrence of the step towards either left plus right, that must be equal to 1. So either half or half is equal to 1, or whatever. This type of combinations can be seen there. So in random walk problem, mean number of steps taken to the right n1 bar are, okay, so it is a product of total number of steps multiplied by the probability that the steps taken will be on the right hand side. So NP is the correct answer of this. So NQ is the this is what the answer for n2 bar, or third is n into P minus Q. That is also not correct, and this NPQ is also a different thing there. So this is question number 22. Question number 23. In random walk problem, mean number of steps taken to the left n2 are, as I said earlier. If NP is the for the right hand side, then left hand side is given by NQ, provided Q is the probability that the step taken will be on the left hand side. So this is again a product of total number of steps into the probability of occurrence of the step to the left hand side. Then question number 24. In random walk problem, mean displacement m bar is given by, okay, so this is given by, we can calculate this as follows. So question number 24. In random walk problem, mean displacement m bar is given by. For that already we have seen this n1 bar is given by n times p, n2 bar is given by n times q. So when I add these two, so when I add this n1 bar plus n2 bar, that gives me np plus nq, or sorry, small q. Therefore this is capital N into p plus q. Because already we have seen this total probability of left hand side and right hand side, that is going to be 1. So that is gives me capital N. So this n1 bar plus n2 bar is equal to capital N. So average to the left hand side as well as plus average to the right hand side. This average number of steps to the left hand side plus average number of steps to the right hand side, this must be equal to the total number of steps. Now the mean displacement is given by m bar is equal to n1 minus n2 bar, or average of this. Statistically we can write this to be n1 bar minus n2 bar. So if I use these earlier relations for n1 bar and n2 bar there, so this m bar or the mean displacement can be given by np minus nq, and therefore final answer will be n into p minus q. So this is the expression for mean displacement, and therefore the correct answer of this question number 24 is 3 n into p minus q. Now question number 25, in random walk problem, mean square deviation. Actually mean square deviation is given by delta n1 bar square. Okay, so this is given by delta n1 bar square. So this is called as mean square deviation, and the correct answer of this mean square deviation is given by product of capital N into p into q. So npq is the product that gives you the mean square deviation in case of random walk problem or the binomial distribution. Then for Gaussian probability distribution, the mean value of x is given by, in Gaussian probability distribution, as we have seen earlier, this np is the probability of this, or n1 bar, nq is the n2 bar, and this mu is defined as, okay, if you remember in the theory, mu is given by capital N into p minus q into small l. So this quantity is called as the mean value of the x bar. So question number 26, the correct answer is the mu. And then last question, for Gaussian probability distribution, mean square deviation, that is we have to calculate this to be delta x square bar. So this mean square deviation of our dispersion, that is given by delta x square bar, delta x bar square. It is given by another simple relationship, and that is given by sigma square. So this is the correct answer of this question number 27. So all these problems are taken to be very, very simple problems, which are completely based upon chapter number 1, 2 and 3. Out of this, these questions based upon onwards 22 onwards 27, these requires some mathematical understanding, the concept of statistics, concept of probability and all these things. Yes. So here we have to study this random walk problem, binomial distribution and the Gaussian distribution well, then we can understand each and every term here. So in the next video we are going to discuss few more problems on remaining chapters from this statistical mechanics or thermodynamics and statistical mechanics. So thank you once again for kind listening. So we'll meet once again in the next video later on. Thank you.